Okay, so let's talk about something that's happening right under the hood of basically every single piece of software you've ever used. It's this epic showdown between two totally different ways of thinking about code, the compiler versus the interpreter.
So here's the game plan. We're going to start with the basic problem that we're trying to solve. Then we'll introduce our two big contenders, the compiler and the interpreter, and pit them against each other to see how they stack up. And finally, we're going to get into a really cool modern plot twist that kind of blurs the lines between them. Let's dive in. All right, section 1, from human to machine. Let's look at the core challenge here.
So this is the fundamental problem, right? We as humans write code in languages like Python or C++ that use words we can understand. But the computer's processor? It's way simpler. It only gets one thing, a raw stream of ones and zeros, what we call machine code. So how on earth do we bridge that huge gap?
Well, pretty obviously, we need a translator. We need some kind of program that acts as a go-between, taking our human-friendly source code and turning it into the machine's native language.
And it turns out, the programming world came up with two main ways to solve this problem, each with a totally different philosophy on how to get it done. And those are the compiler and the interpreter.
First up, let's meet the compiler. This thing is an absolute powerhouse of ahead-of-time translation.
Now, the key thing to get about a compiler is that it does all of its work up front. I mean, all of it. It reads your entire program, analyzes every single line, and then spits out a completely separate, ready-to-run file, an executable, that the processor can understand directly. The best way to think about this is like translating a whole book. You do the entire translation from, say, Spanish to English all at once. When it's done, you hand over the finished English version. You don't need the original author or the translator anymore. You just have the final product. That's a compiled program.
But, this isn't just a simple one-and-done thing. It's actually a pretty sophisticated process. It starts by breaking your code into little pieces, or tokens. Then it checks if your grammar is correct, kind of like a spell checker. And after some other steps, it gets to my favorite part, optimization. This is where the compiler gets really smart, rearranging things to make the final program run way, way faster. It's a whole assembly line of refinement.
And you can see that whole process right here in this diagram. It's like this waterfall, right? Your source code goes in at the top, gets broken down, checked, optimized, and then at the very bottom, out comes that pure, super efficient machine code. And this whole upfront process is exactly why compiled programs are so incredibly fast.
Okay, so that's the compiler. Now let's switch gears and meet our other contender, which has a completely different style, the interpreter. The interpreter, it's a completely different beast. It doesn't create some separate file beforehand. Nope, it works in real time. It reads your code and executes it right then and there, one line at a time, on the fly.
This is a perfect analogy, right? The UN interpreter translating a speech live. There's no pre-translated document. The translation happens in the moment, sentence by sentence. And this immediate feedback loop is fantastic for developers. It makes writing, testing, and especially debugging your code so much faster. All right, so we've met both sides. Now let's put them head to head. It's time for the showdown. Compiler versus interpreter.
So this table really breaks down the trade-offs, and you can see them right away. Compilers, you get blazing fast execution speed, because all the translation work is already done. But with interpreters, debugging is way easier, because they literally stop on the exact line where something goes wrong. It's a classic give and take.
At the end of the day, it really boils down to this. What do you care about more? Raw speed or how easy it is to develop and debug? If you're building, a high-performance video game, you're probably going to want a compiler. But if you're just writing a quick script for a small task, an interpreter is your best friend, for sure. And it's not just about speed and debugging. There's another huge difference: memory and portability. The compiler creates this extra file that takes up space. The interpreter, though, it doesn't need that. It just runs your source code directly. This makes interpreted programs leaner and, this is huge, more portable. You can take the exact same Python script and run it on a Mac, a Windows PC, a Linux machine. As long as they have the Python interpreter, you're good to go. But hold on, because here's where things get really interesting in the modern world. That strict line between compiled and interpreted, it's not so clear anymore. In fact, it's gotten really, really blurry.
Yeah, exactly. This developer on Stack Exchange totally nailed it.
Trying to force every language into one of two boxes just doesn't work anymore. It's an old way of thinking.
So how do they do it? Well, a ton of the languages you probably use every day, like Java and Python, they do something really clever. They use a hybrid approach. They start by compiling your code, but not into machine code. Instead, they compile it into this universal, intermediate language called bytecode.
And this is the real magic trick. A program called a virtual machine starts by interpreting that bytecode, but it's also watching what your code is doing. When it sees a piece of code that gets run over and over and over again, a hotspot, it compiles just that little piece into super fast native machine code right then and there. It's called just-in-time or JIT compilation, and it gives you the best of both worlds, portability and amazing performance.
Okay, but you might be thinking, if JIT is so awesome, why isn't everything done this way? And that's a fair question. The thing is, for some jobs, you need guaranteed top-tier performance from the very first nanosecond. Think about your computer's operating system. There's no warm-up time allowed. So it's not just about speed, it's about control and predictability.
So the big takeaway here isn't which one is better. That's the wrong question. The real question is, what's the right tool for the job? Compilers are still the kings for performance-critical stuff. Interpreters are absolute champions for getting things done quickly and easily. And these modern hybrid JIT models, they're the powerful compromise that's taken over the world of high-level languages.
And that leaves us with a really cool question to think about for the future. As our computers keep getting faster and these JIT compilers get even smarter, are we going to reach a point where that upfront performance gain from a traditional compiler just doesn't matter for most things anymore? It's a fascinating ongoing evolution, and it'll be really exciting to see where that balance between pure power and clever flexibility lands next.